Hello, dear students of 10th class, respected teachers, respected parents, and my dear friends. So, today I am going to discuss Ohm's law and resistance from the chapter of electricity, especially for 10th class. So, first of all, what is Ohm's law? And in the first video of electricity, I have said when a potential difference is applied across a wire or a conductor, then each and every electron starts drifting toward the positive end of the conductor, and the velocity with which electron is drifted toward the positive end is called drift velocity, and hence current starts flowing through the conductor. The direction of current is taken from positive to negative end of the conductor or negative to positive through the battery, which is opposite to the flow of electrons, direction of flow of electrons. So this is called conventional current, and direction of flow of electrons is called electronic current. This we have already discussed in first video that belongs to electricity introduction. Now, what is Ohm's law? Now, Ohm's law states that potential difference across the ends of the conductor is directly proportional to current flowing through the conductor, and this implies V is equal to IR, or V upon I is equal to constant, and this constant is called R, resistance of the conductor. So this is nothing but Ohm's law. I repeat, it states that potential difference across the ends of a conductor is directly proportional to current flowing through the conductor, and the cause of current is flow of electrons from one end of the conductor to the other end. In other words, V upon I remains constant, and this constant is called resistance of the conductor. So mathematically, the resistance of a conductor is defined as the ratio of potential difference to the current flowing through the conductor. But this resistance is independent of voltage or current, because more is the voltage, more is the current. This ratio V upon I remains constant. Resistance depends upon some other factors. I will discuss it later on. So V upon I is always constant. Now, when V is equal to 1 volt, I is equal to 1 ampere, then R is equal to 1 ohm. So ohm is the unit of resistance in SI system. So resistance of a conductor is said to be 1 ohm when a potential difference of 1 volt produces a current of 1 ampere through the conductor. Very simple. So R is measured in ohm in SI system. Now, this is mathematical definition of resistance. What is theoretical definition of resistance? What is the cause of resistance? Now, we have said that when there is no potential difference, then the free electrons of the conductor move in random fashion. They follow zigzag path. It means net flow of charge in a particular direction is zero. That's why there is no current. So when there is no potential difference, there is no current. But when potential difference is applied, each and every free electron of the conductor starts drifting toward the positive end in a particular direction. Now, it has to collide with the atoms or molecules of the conductor. At every collision, energy is lost. So, energy gained by the electron due to potential difference is lost at every inelastic collision of the electron with the atoms or the molecules of the conductor. So, due to inelastic collisions of the free electrons with the atoms or molecules of the conductor, kinetic energy of free electrons is lost. So, their velocity is reduced to very small value called drift velocity. Even velocity of free electron is very high when there is no potential difference. So, that kinetic energy, that loss in kinetic energy appears in the form of heat. So, that's why wire becomes hot when current is allowed to pass through the wire or a conductor. So the cause of resistance is the inelastic collisions of the free electrons when they are drifted toward the positive end of the conductor under the influence of electric field or hence potential difference. So this is the cause of resistance. Now, what are the factors upon which resistance depends? What are the factors upon which resistance of a conductor depends? Number one, resistance of a conductor is directly proportional to length of the conductor. More is the length, more is the conductor resistance of the conductor. So if we have two wires of copper, say first wire is 1 meter long, second wire is 2 meter long, having same thickness, then resistance of 2 meter long wire of copper will be double that of 1 meter wire. So it means resistance is directly proportional to length of the wire or conductor. More is the length of the conductor, more is the resistance. Simple. Second factor, resistance is inversely proportional to area of cross section of the conductor. This area. So it means if you have two wires of copper, one is thick and one is thin, but having same length, say 1 meter each, then resistance of thinner wire will be more than that of the thick wire. So resistance is inversely proportional to area of cross section. In thick wire, current flows easily because distance is less. So if we combine these two factors, so you get R is proportional to L upon A, or R is equal to rho into L upon A. Where rho is known as specific resistance of the conductor or resistivity of the conductor, or we can write rho is equal to R into A by L. Now, if R is equal to 1 ohm, A is equal to 1 unit, again 1 meter square, you can say, L is equal to 1 meter. Then specific resistance or resistivity has units ohm meter. Ohm meter. So ohm meter unit of specific resistance or resistivity in SI system. So specific resistance or resistivity is the property of the material of the conductor. Means resistivity doesn't depend upon the dimensions of the conductor. Even resistance depends upon length, area of cross section, but resistivity doesn't depend upon dimensions of the conductor. Both resistance and resistivity depend upon nature of the material of the conductor as well as temperature of the conductor. So both resistance and resistivity depend upon nature of the material of the conductor. Second, depend upon temperature of the material of the conductor. So for metals, resistance and hence resistivity increases with the increase of temperature. But in case of semiconductors and electrolytes, resistivity decreases with the increase of temperature. So this is the difference between resistance and resistivity. Or you can say, if we take R is equal to 1 ohm, the rho will be equal to when L is equal to 1 meter, area is equal to 1 meter square, 1 unit, and rho is equal to R. And L is equal to 1 unit, 1 meter, area is equal to 1 meter square. Means when we have a cube of length 1 meter and area 1 meter square, so we have a cube of side 1 meter. So it means resistivity is nothing but resistance of the unit cube of the conductor. So if you have unit cube of the material of the conductor, the resistance of that unit cube is also called resistivity or specific resistance of the conductor. So that's why it doesn't depend upon dimensions of the conductor. It depends only upon nature of the material of the conductor as well as temperature of the conductor. So these are the factors upon which resistance and resistivity depend. Very easy. Then we define conductance C. So conductance is defined as reciprocal resistance. Reciprocal resistance is called conductance. So unit of resistance is ohm. So unit of conductance will be ohm inverse, or it is called mho or Simon. So mho or Simon or ohm inverse is the unit of conductance of a conductor. Then we define another definition: conductivity, electrical conductivity. It is defined as ratio of reciprocal of resistivity. So reciprocal of resistivity is called conductivity. Reciprocal resistance is called conductance of the conductor. So conductance is measured in ohm inverse, mho or Simon. The conductivity will be measured in ohm inverse, meter inverse, or mho per meter, or you can say mho per meter or Simon per meter. So these are units of electrical conductivity of a conductor. So we have defined resistance of the conductor, which is defined as ratio of voltage to current. Resistivity of the conductor, specific resistance, which is unit resistance or unit of cube of the conductor. Conductance, reciprocal of resistance, and it is measured in mho, Simon, SI system. Conductivity, reciprocal of resistivity. Then there are ohmic and non-ohmic devices. Ohmic devices are those for which resistance is constant, or graph between V and I comes out to be a straight line, or which obey Ohm's law. V is proportional to I. Those devices or resistors which obey Ohm's law are known as ohmic devices. And in ohmic devices, V is proportional to I, it obeys Ohm's law. For example, all metals obey Ohm's law. Non-ohmic devices means which do not obey Ohm's law, like semiconductors. So graph between V and I for semiconductor comes out to be like this. It's not a straight line. So semiconductor as well as electrolytes, they do not obey Ohm's law. They are non-ohmic devices. Question may be asked, what are ohmic devices and what are non-ohmic devices? Give examples. So those devices which obey Ohm's law are called ohmic devices. For example, our metals obey Ohm's law. Second, those devices or resistors which do not obey Ohm's law are called non-ohmic devices. So for example, semiconductors and electrolytes are non-ohmic devices. So this is simple. Ohm's law and resistance, upon what factor resistance depends. Again, I repeat, Ohm's law is nothing. Potential difference across the ends of conductor is directly proportional to current flowing through the conductor. That is V upon I, ratio remains constant. This constant is called resistance. Resistance is measured in ohm. Resistance is directly equal to length of the conductor, inversely equal to area of cross section, and is given by R equal rho into L upon A. Rho is called constant of proportionality and is called specific resistance or resistivity of the material of the conductor. So both resistance and resistivity depend upon nature of material of the conductor, temperature of the material of the conductor, but resistance depends upon dimensions of the conductor. Resistivity doesn't depend upon dimensions of the conductor. And unit of resistivity is ohm meter. In other words, resistivity is the unit resistance of unit cube of the conductor, having length 1 meter and area of cross section 1 meter square. Then what is conductance? Reciprocal resistance is called conductance. Reciprocal resistivity is called conductivity. And unit of conductance is mho, Simon, or ohmic devices are those which obey Ohm's law. All metals obey Ohm's law. Non-ohmic devices like semiconductor and electrolytes, they do not obey Ohm's law. This is non-ohmic devices. So this is all about Ohm's law and resistance. In next video, I will discuss resistance in series and parallel. So, dear students, ਜੇ ਮੇਰੀ ਵੀਡੀਓ ਚੰਗੀ ਲੱਗਦੀ ਹੈ ਪਲੀਜ਼ ਵੱਧ ਤੋਂ ਵੱਧ ਸਟੂਡੈਂਟਸ ਨੂੰ ਆਪਣੇ ਨੂੰ ਲਾਈਕ ਸ਼ੇਅਰ ਕਮੈਂਟ ਕਰੋ ਔਰ ਮੇਰੀ ਵੀਡੀਓ ਦੇਖ ਕੇ ਆਪਣਾ ਬਿਨਾਂ ਪੈਸਿਆਂ ਤੋਂ ਘਰ ਬੈਠੇ